Hello guys, welcome back to my YouTube channel. And since I'm going to upload heap short in an upcoming part, but before understanding heap short, we need to understand what heaps are and what are max heap and min heap, and also UpHeapify and downheapify methods, which are also the insertion and deletion methods in heaps. So before understanding heap short, we need to understand what are heaps and UpHeapify and downheapify methods. So let us start with understanding them. So, a heap. What is a heap? A heap, we can say that a heap is a complete or almost complete binary tree. We know that complete binary trees are the binary trees in which every node has two childs, left and right child. And an almost complete binary tree is that some nodes may or may not have left or right child, but the child should be in the extreme left position. For example, if I want to add a child to this 10, this node 10, I will add this to the extreme left position only. So if I want to add one child to 10, this will only be here at the extreme left position, not here at the right position. So this will still be considered as a heap. So this is what almost complete binary trees are. And let us suppose I want to add another child. So I will add it here, not at the 12. And if I want to add another child, then this will be added here. So in this order, childs will be added from the left position to the right position. These are these are what are called almost complete binary trees. So let me just delete them. Okay. Now we understood what heaps are. Now what are min and max heap? In a min heap, the root element always holds the minimum. The root element is always the minimum. So what do we understand by this? That if in a min heap, if we check every node, then its root should be lesser than it. For example, let us suppose we check 4. What is its root? Its root is 2. It should be lesser than it. And 2 is less than 4. If we check 5, 5 is less than 2. So, which is also the true condition for min heap. Then we again check 8. Is is 4 less than 8? Yes, 4 is lesser than 8. Is 4 lesser than 10? Yes, 4 is lesser than 10. Now 5. We have 7. Is 7 greater than 5? Yes, 7 is greater than 5. Is 12 greater than 5? Yes, 12 is greater than 5. So the root is always lesser than its child elements. The root holds the minimum element. This is the condition which is true for min heap. The parent element will always be lesser than its child for every node. The label order reversal for this would be 2, 4, 5, then 8, 10, 7, 2. This would be the label order reversal for min heap. Now, what does min heap guarantee? That if we remove an element, it will always be minimum. So from this array, if I remove an element, I will always remove from the front. That is, I will always remove the root. If I remove this root, this will be 2. So this will be the minimum element from all this. Uh, please note that equality also holds. So this can also be 4 here. Since both are 4, so we can make any 4 here. Equality also holds in this condition. So in min heap, if I want to remove an element, always the minimum element will be removed. For example, if I remove an element from this, 2 will be removed. And yes, this will be the case. But in max heap, what is the max heap condition? Root always holds the maximum value. For example, 15. What is its root? It's 20. Its root should always be greater than this. Is 20 greater than 15? Yes. And it's the same example here. The roots always hold the maximum value. And this is the label order traversal. If I want to remove an element, I will remove it from the root. And it will always be greater. Okay. So this is what min heap and max heap are. Now we will use max heap. We will use max heap for the heap short technique. So let us understand how do we insert and how do we how do we delete element from the max heap. So for insertion of an element in max heap, What we do is we insert. So first of all, let us understand how to find the parent of an index. From here, you can see the 6. What is the parent of 6? It is 18. We can clearly see. But in this array representation, we need to find the parent index using an array representation. So, for example, we know that this is 0. We know that this is 0th index for level 1 traversal. This is 1. This is 2. This is 3. This is 4. This is 5. And this is 6. Okay. So this is the 0th, 1th, 2nd, 3rd, 4th, 5th, and 6th. So the parent of any index, for example, I want to find the parents of this 6th index, would be index minus 1 divided by 2. This is how I can find the parent of any index from its position. So this is how I will find the parent. So let's suppose I want to find the parent of 6. What would be the 6th index? 1 divided by 2. What would be it? It would be 2. Okay. So we know that 0, 1, 2. 18 is the parent of 6. So that's how we find. For example, I want to find the parent of this 10, which have an index 3. So what would be the index of 3 minus 1 divided by 2, which would be equals to 2 divided by 2, which is 1. So 10 has its parent 1, which is 15. So this is how I can find the parent of every index. What will be the use of it? We will see in the upcoming code, but this condition should be clear that how to find the parent of an index. I will find, so this is the array which is there. So now let us start by inserting an element. How to insert an element in the max heap. So for example, let us consider I want to insert a 19 here. What would I want to insert here? I want to insert a 19 here. So I will insert it at the almost left position. But since this will, what will the index of it? Well, let's suppose it's 7. So it will come here. At first it will come here. 19 will come here, sorry. In this array, 19 will come here. 19 will come after this. So this would be the next array. Okay. Now, since we know this is not satisfying the condition for max heap. Well, how is it not satisfying the condition for max heap? 10 should be greater than 19 because it's its parent, and in the max heap condition, parent should be greater. So what I will do is I will replace this 19 with this 10. So I will have 19 here and 10 here. I will get 19 here and 10 here. Now we will check. This is 12 and this is 19. Is 19 and 15 satisfying the condition for max heap? No, they are not, because 19 should be above 15 because it's a max heap and root is always the maximum. So 19 will get out of here and we will check it. 15, we will get 15 here and 19 here. Okay, so now max heap is, now if we check that 19 and 20, are they in the correct position? Yes, they are in the correct position. So now our max heap is maintained. So this is what is called UpHeapify. When we insert an element in the array, but in the heap, but we still need to UpHeapify that because it might not come to its correct position. Now here, how will we check that in array? For checking that in array, what we will do is we will insert 19 at this position, at the last of the array. And what is this index? This is 1, 2, 3, 4, 5, 6, 7, 8. So this is the seventh index. Now I will find the what is the parent for seventh index? Parent for seventh index will be 7 minus 1 divided by 2, which is equals to, this is 6, which is 3. So the parent for seventh index is 3. So 3, 0, 1, 2, 3. This is the parent. And we also know that we replace 10 here for the array. So 10 will be the parent for this index. 10 will be the parent for this index. Now I will replace, since it is smaller than this index, so I will replace this 19 with this 10. Okay. So I have used in this array because we are not going to make a tree actually. So we will update in array only. So this 19 and 10 are replaced. Now I will again find the parent for this third index. What would be the parent for third index? 3 minus 1 divided by 2, which would be equals to 2 by 2, which is 1. So this would be the index 15. Is 15 larger than 19? No. So we'll swap. So I will swap 15 with 19. Okay. Now we have this as our array. And now this is sorted because now we'll check the new parent, which will be 1 minus 1 divided by 2, which will be 0, and 0, which is 20. 20 is already greater than 19. So this is the array which is updated after inserting an element. So this is how we insert an element in the max heap. Okay, that is it for today. I will make the video for deletion from the max heap in the next video. Thank you.